Hello, welcome. This is TIS-100, or it's going to be in a moment at least. So before I actually launch the game, a few things to say. One, this is going to be kind of weird and complicated to record. Two, I tried something different than what I usually do. I had a list of several games that could go in this slot, and they all looked about as good as any of the others. I decided to use this new thing on YouTube called a community post. I have no insight into how it actually looks when I make it, but a bunch of people found the post that I made, which included a poll for which game to play next. The result was anything but decisive. Almost all the options I presented were not far off from tied, but this one did get the most votes, so this is what I'm doing today. Alright, so let's try launch TIS-100. Did I press the button? I pressed A key. I don't know if I pressed the right key. There it goes. Okay, so sometimes the window appears in one place, sometimes it appears in a different place. Come on, cursor. Let me move this. There we go. That'll do. Okay, so you kind of missed that. There was some sort of startup sequence. The multi-display setup I use for recording messes with apparently where the window likes to position itself. Sometimes it just makes like a 720p window on the main screen, but sometimes it goes between the two. I don't know what makes it decide one or the other. Anyway, the other thing is the first time I launched this, it strongly recommended that I look at the PDF manual that comes with it. It recommends printing it. I don't like to print things. I mean, I could, but I don't like to. So I'm just going to keep it in a browser here in the background and switch back and forth as necessary and hope that works. We are all still in shock here from Uncle Randy's sudden passing. While we wait on word from the examiner about the cause, we're coping as best we can. Period. I've been occupying myself sorting through his things, especially his computers. Of course, I took one look in the garage, and it all looks like a bunch of junk to me. I'll send some pictures when I get a chance. For now, this is the machine that was set up on his workbench when he died. Maybe you'll be able to figure out what he was doing with it. He would have liked to know someone was going to finish his work. Love, Aunt Doris. The Tessellated Intelligence System is a massively parallel computer architecture composed of non-uniformly interconnected heterogeneous nodes. The Tessellated Intelligence System is ideal for applications requiring complex data stream processing such as automated financial trading, bulk data collection, and civilian behavioral analysis. This part is highlighted in black and white. Notes like this one will appear in this manual to indicate scenarios requiring special attention and to refer to other documents that contain more information on a topic. So this is a programming game of sorts. Don't know a huge amount about it beyond that. Like, I don't even know what kind of structure this game is going to follow. But it's come highly recommended to me. Alright, let's not read this word for word. Large number of independent nodes, on a local basis, model-specific manual. Processing or storage. Several variants within each category. Great. Ports. Up to 4 neighbors. Okay, so it's like spatial. So I'm assuming like these things are what the nodes are going to look like. I've seen some footage of what this looks like running. Let's keep reading this since it really wanted me to read this whole document first. Lightweight message passing. Great. Issue a read or a write to a port and blocking until the request is filled. Great. I gotcha. If 2 nodes are both trying to read or write from each other, they'll deadlock and a hardware fault will occur. Okay, so don't let them deadlock. Gotcha. So that's probably a failure condition or like something I would generally want to avoid. Node will deadlock and hardware fault will occur. Wait, so like if it blocks on a port for too long? Exceptions exist. Refer to documentation of specific node types. All right, great. Does not describe timing or throughput. See, like, I feel like I should start the game, then refer to all this when I need to know it. I mean, this is interesting stuff, but let's get an idea of what we're actually doing here before going through all that. So I'm at the TIS-100 segment map. I can go to the specification editor. Sounds like this is like a level editor, basically, is my current impression. So I'll leave it alone for the moment, at least. These look like save slots to me. Oh. Self-test diagnostic. I said that really weird. Diagnostic. Read a value from in.x and write the value to out.x. Read a value from in.a and write the value to out.a. Okay, so in.x, in.a, out.x, out.a. So if I just run, move up, down, idle, got to the end. What happens when it's slowing down? Those have communication failures. This one has a debug button on it. Microcode dump. Can't find a pen right now, so I'm just going to take notes here. Looks like short-term storage. Got this one at the swap meet today. Fellow wanted 450, but I talked him down to 200. Good deal. No idea who makes this thing. Never heard of the TIS series, and the architecture doesn't look like anything I've seen before. Ask the guys down at the something but no joy. Randy has a mystery on his hands. Randy. So Randy would be Uncle Randy. He's dead. I inherited his computer. And I'm trying to figure out what he was trying to do with it, apparently, as the story here. Do I know what type of node any of these are? Idle's still sitting at 90. Okay, so it's still rising slowly. Let's stop. So let me see if I can... Okay, so this is just a freeform text editor. Gotcha. Cool. Communication failure, debug. Okay, so those are the node directions or something. All right, so same thing there. Okay, so read a value from in.x and write the value to out.x. Read from in.a, write to out.a. Move up, down. Okay, so last... all right, so what do I need to know for that? T20 reserved, to specific models, not be described. Okay, so T20 is a mystery. Don't even know what T20 means at this point. Basic execution node, T21. So are these T21s? How would I tell? I don't know. Okay. Basic execution node specifies computational and communication. Okay, sure. Execution automatically continues. Right, so that's the looping that I saw there. So it's just looping through move up, down. So I need to know what those mean. All right. Registers, yes. No additional memory, so the only storage I get is registers. That's cool. So not a binary number storage system, it's decimal. How strange. Implementation defined. Okay, so here are possibly commands? No, these are registers. Implicit source or destination. All right, so ACC. I'm trying to figure out if that's like accumulator or something. Accumulated value. I don't actually know assembly language programming. This is going to teach me a lot of stuff. I have peripherally learned a few things about it, but I've never like written any assembly code or read much and like actually understood it. Temporary storage. Cannot be read or written directly. Reading nil produces 0. Writing nil has no effect. Great. Okay. Here we go. Left, right, up, down. So I'm seeing move, up, down. Port. Ah, up, down, left, and right. So those are the ports. I gotcha. Some will be disconnected. Indefinitely will block if right, of course. Refer to the interconnection diagram. So I'm assuming that's this. Move up, down. Out.x is here. What is the... Okay, so in.x. Still not sure. In.a. Okay. any port. Read the first value that becomes available. Write to the first one that wants to read, of course. Last. Okay, I gotcha. Great. Instructions. This is what I need. Port or internal register. Yes, go away. Any use of a port will block until blah, blah, blah. And you can enter literals. Great. Back cannot be specified. Okay, so there are labels for go-to. Gotcha. Comments exist. You can title your program like that. Debugger. Okay, great. Labels are used to identify. Okay, I gotcha. Cool. So they can appear on the same line. Gotcha. No op. All right, source is read and the resulting value is written to dest. Move up, nil. Value is read from the up port and then discarded. Okay, so I'm guessing this. Okay, so what's with the arrows here? This points in this direction. This points in both directions. So it feels like this loops around like this. I can read from up, which means, okay, so if I'd move from up here to down here, this is just sort of passing data around in a loop and doing nothing with it. But there's no, like... Yeah, so this is just a weird self-referential loop. There's no actual data being read. It's just like making a connection and moving nothing around. So a whole lot of read and write requests with no actual data in the middle. Okay, so hang on. Read the value from in.x and write the value to out.x. So in.x comes in here, out.x goes there. So this needs to move. Yeah, okay, I think I get it. So all I need to basically do here is move up to, I need to write this to out.x. Well, no, wait, why doesn't this actually just work? Does it actually just work? No, I get it. This is an example. Gotcha. Okay, I think I know everything I need to do to solve this at this point. In.a, out.a. So, move. Let's just infer. Move up, left. Move right, down. I'm just going to avoid the ones with the communication failures. All right, so have I understood this correctly? I sure have. I did it. Test 1 passed in 83 cycles, test 2 passed in whatever. Cool. I did it. All right, and those are my statistics. Cool. So this is a Zectronics game. These graphics, these graphs are like measurements of how well I did that task. I can optimize for different things, I believe. But I'm going to be happy with this solution. Seems like this is the best cycle count I'm going to be able to do, like it's at the left end of the graph. Okay, cool. All right, well, I understood enough to do the self-test diagnostic. All right, return to segment list. Great. So I finished the first level, the tutorial. Signal amplifier. Let's do it. Right, so those are my statistics. This is like, I guess, other people's statistics or something? Oh, okay, so I create a new program for each. Gotcha. All right, cool. Signal amplifier. Read a value from in.a, double the value, write the value to out.a. Great. So I'm going to need like an add or a multiply. So in.a, write to out.a. All right, so the shortest route is like that. So any one of these cores could certainly just do the addition or the multiplication itself, right? All right, so tell me again about the registers. ACK, right. Okay, I gotcha. Probably just going to be like an add command. There sure is. I'll bet this is all I need. ACK register and left. All right, so let's just say move up. No, wait, can I just like... That's probably valid. That might be valid. I don't know. Let's try this. I want to type move the correct way. All right, what do you think of that? Seems valid. Okay. Great. I did it. Okay. Well, that's simple enough. All right. Oh, hey, many things are open. Hold on. Let me look at this again. There is a debug button here. Continues to baffle. Chatted with Bernie at IBM, and he says it sounds like something they'd come up with in the USSR, but then why is the manual in English? A mystery. All right, so go back. Return to the segment list. All right, differential converter. Let's do it. Create new program. Read from in.a and in.b, write in.a minus in.b to out.p, b minus a to out.n. P is here, n is here, a and b. Okay, I gotcha. A minus b, b minus a. All right, this is just phrased to be hard to think about, is what I feel like. Okay, to out.p. All right, so this is just going to be like, okay, so tell me about my registers again. ACK, back, nil, and those. Okay, so an any, last. So here I need something. Do I have a sub command? Probably. I have add, so I have sub. Yeah, same thing. Okay, yep, I gotcha. That's what I figured. Okay, so I need to move from up into something. Okay, so here's where things get real interesting. Fascinating. So I'm gonna probably, hang on, let's read this. Interesting, it looks like something. There's some kind of static memory in this thing, encoded something or other. Oh, okay. Let's just write some stuff. I'll paint myself into a corner momentarily. This accomplishes absolutely nothing. There's no reason I would do this, other than if I just want to move these closer to their destinations. Which I might want to do. Like, why would I not just do the operations? Let's see. So these are going to have to talk to each other at some point. All right, so here's what I'm thinking. So if I read in.b, and then oh boy, how will this work? Why would I do this? So there's no reason to go via that register. So if I just move up, left, I have kind of an idea I'm working here. No, I don't want to do this. So you're going to read it into your memory. Then you're going to read from, whoa. No, that's not what I want. I want to, I want to do that. So you're going to write to there, I'll worry about you in a minute. So then you need to do an operation. So basically I'm going to have operations happening here, storage here, or something like that. I'm not sure yet. I could look up more commands that might help me here, but I don't think I'm going to need much more than that. So if I use this register... Man, I had an idea, but it's hard to hold in my head and do all this at the same time. This core is going to be twice as busy as these two, so these are going to block on output. So this won't be efficient, but that's fine. I'm not optimizing for efficiency at the moment. What am I trying to do? I want to sub something. So you're moving that out of there. You have not read... So this core has not read from this core yet. Right, but this is where I do that. So in this register, so I move the unmodified value of in.a over here. Then I'm going to modify it by subtracting in.b from it. Sub right, right? Sure. So then something perfectly suited for output to out.p will go down here. It looks as though I'm going to have to cross over. Ah, fascinating. So like if to go with this plan, basically like you've done the necessary operations, but there's something spatially residing right here that has to cross over to here. Then I have something spatially residing over here that I want to put there. So some sort of I/O operation is going to have to alternate between these two, which it should be able to do, right? Let's see about this. Okay, so move, but you, okay, so you have the value of in.b in you. Oh dear. Wait, this has just gotten more complicated. I think there's a simpler way to do that without involving this column, I would imagine. This is a game where I'm going to have a lot more trouble than usual explaining my thought process in a way that's understandable. My mind moves faster than my mouth is able to for this. Kind of. My internal cores don't have enough cycles to run both at full capacity here. Anyway, so here I have... like this will work for out.p, right? This will just block here forever. Well, no, so hold up. Let's write a failing program and see if it will halfway succeed. So let's see if at least out.p is correct. Okay, so that does seem to execute correctly for out.p. So now all I have to do is get this value out. So, no, wait, get this value. Oh, okay. Here, I can do this. Easy. There we go. That'll run. Oh. I have an error. Why? What have I done? I've mixed my something up. Wait, what happened? I'm reading at double speed here. Awesome. Okay, right. So moving from in.b advances the line counter, so that's what I did wrong. All right, so this is why I need to do. I need to use the register here. All right. Excellent. All right, so I do one read, then I send it off to both of these places. This does the one sub that ends up here. This does the other sub that This is completely pointless. Wait, no it's not. No it's not. Right, these have to cross over here. Technically they don't. I could avoid this crossing by going this route. Oh, okay. Well, this is slightly unnecessary, but I'll take it. Something's still wrong. Move up, ack, move ack, left, move ack, down. Left, ack, sub up. Move ack, down. Up, down, left, right. So in dot A. Got it. I'm using the same values for both. That's the problem. I need to sub the other way around. So I need to move up, ack, and sub left. There we go. Sweet. This is super cool. Oh man. I like it. And like, this is just using like a few very basic commands. Let's see, so I'm there, and there. Okay, so not far from the middle of the average efficiency. I'm a little worse on node count. Right, because I didn't really have to involve these two. These two are doing absolutely nothing. Why did I involve those two? That's fine. Doesn't matter. Okay, let's do one more. Signal comparator. Read a value from in, write 1 if greater than... Okay, gotcha. So, comparator in that sense. When A1 is not written to an output, write A0 instead. What are you saying? Found a block of static memory, but it's in a proprietary format I never saw before. Can't make heads or tails of it. No, brother, there's just too many different kinds of machines coming out now. And I like tinkering with them as much as the next guy, but when every Tom, Dick, and Mary implements their own memory address scheme, it's all something. Bottom's going to drop out of the microcomputer market soon. Okay, so this is my inputs. All right, so I need to compare. Example programs, sure, whatever. Where do I... Okay, so that's how I use that register. Great. All right, so swap or just overwrite. Cool, I understand that. Already used that, already used that. Right, and remember that you can use numeric literals in add and sub. So negate, unary negation, excellent. So that's go to. Jez, what is that? Instruction after label will be executed if value is 0. Okay. Not 0, positive. Negative. All right, so it looks like these are what I need to use for this. Transfer unconditionally. Oh boy, offset. Okay. Fantastic. Okay. So I don't need JRow. Example programs, okay, stuff. What I do need is Jez, Jugs, and Jules. Right? Probably. Instruction after the label. Alright, so what do you say again? .g, .e, .l. Right, 1 if it's greater than 0. Okay, so. Seems right. Okay, so I want to either... So out.g if greater than 0. So I want, which one is that? Jigs. Undefined label, sure. Does it need to be before or after? can be anywhere. That's fine. Wait, but what does it do if it will be executed next? So then unconditional, oh, I see. All right. Sounds reasonable. So if it doesn't go here, no, but by putting this here, I have, so there's probably no, like, highlighting. There's highlighting. All right, great. There we go. Do I need to jump past that? Probably. Now hang on. I don't need to mess with JRow. I can just jump, right? Jump to label. There we go. Okay. So this is all unnecessary. So let's do compare. Okay, yes, this is great. This will work. No. What am I doing? Okay, well, I need to actually read the value. Okay, that sounds reasonable, right? So get the value in here. Compare it. And yeah, get rid of all this. So it'll automatically loop if it gets to right. Take me back to compare. I mean, I should call this read and compare. That won't fit, though. I'll just leave it as compare, even though that's slightly wrong. All right, so I should be able to just, like, copy, paste, paste, replace this with which? Okay, jump greater than 0, jump less than 0, jump equals 0. Gotcha. Okay, so that's easy to remember then. Greater equal less. Okay, well, that's easy enough. Jules. Except then I can't do this. So you need to just, like, not do anything. When A1 is not written to an output, write A0 instead. Wait, when a 1 is not written to an output, write a 0 instead. So that means that I need to... do that everywhere. Right? But I don't do this here. Okay, let's see what it does. Doesn't work. Why? So G was correct. E and L were not. Why? Hold on. Well, let's see what the very first E was written as 1. I need like I need to be able to step through this slowly. What's this? Question mark. It's not clickable. If I pause, nothing happens. Okay. Well, I mean, I can just figure out what went wrong. So, the only way you move right is if... Oh, you need to do that unconditionally. I gotcha. Because, right, it's not that you stop comparing all of those. Yeah, I gotcha. All right. So my problem was making this conditional. I want to always do this. Okay. There we go. That's better. This is super cool. This is my jam. Good stuff. All right, I did it. So like the random test, so it's like 3 sets of test data have to pass through here, then a randomly generated one. So the randomly generated one would stop me from writing something that produces the correct output without actually doing the correct action to produce that output. And the different tests, you know, the large size of the data set means I can't just like list out, you know, move 1 down, move 0 down, move 0 down, move 1 down. Like I don't have enough instruction space to do that generally. Okay, looks like I did the most common solution here. Not too surprising. All right, great. Oh, yes. That's, I wonder if this is like all the puzzles in the game. It feels like a small number looking at this, but I think they're going to go much, much slower after this. All right, great. This is super cool. Kind of, yeah, again, kind of weird, unusual LP, but I am feeling good about this right now. All right, I'll see you next time for Signal Multiplexer.